Okay, good afternoon, everybody. Welcome to day 2 of Dreamforce and our talk on using IoT to visualize the health of your orgs, and particularly an interesting way to visualize unit tests. So you've probably spotted this thing. We were very concerned that we wouldn't get it to work since we've had to ship it across from the UK, but it's lit up, so we'll dig into that in a second. First of all, just a quick introduction as to who we are. So I'm Kevin. I'm the CEO of a startup in the UK. We build a Salesforce release management solution. So we're not here to talk about that. We spoke about it yesterday. I'm speaking about it again tomorrow. This is just a fun project that we built to visualize unit test health.
And I'm Jason. I have the lofty title of customer success, but for the purposes of the talk today, I'm going to be the chief tinkerer, talking about how we built this and why we built it and how it works behind the scenes.
Okay, so just to sort of set the scene, we're not going to labor this too much because for the last 3 years I've spoken at Dreamforce each time about how important testing is, and I'm sure I'm almost certainly preaching to the choir. But just as a little bit of context, why is testing important? So first and foremost, it catches problems earlier when you're more in a position to actually do something about it. You can actually fix the issue. So rather than having to wait until weeks later when you've forgotten what you were working on, that unit test going ping and catching your attention will actually make it easier to fix in the long run. The next reason testing is important is that it accurately proves what you were trying to do, what the business requirement was. So if you think of any project, as you go from what the end users actually want through to what the business analysts document in the spec, and then finally through to the admins and developers that have to implement it in code, things can get lost in translation along the way very, very easily. And unit tests are just another way of codifying exactly what it was you were trying to do. They also help to protect your development investment. So obviously we're all the best devs and admins ever today, and we never make mistakes. But what if somebody later joins the team, or what if I'm trying to fix some of my code in 2 weeks and I've forgotten what I was doing a fortnight ago? The unit tests will help to protect me. They'll give me a safety net. They'll help to make sure that I'm catching and making sure I know what I'm doing. And finally, sort of unique to the Salesforce ecosystem is that it's a requirement for deploying code. You can't deploy to production without having your unit tests running and suitable code coverage. But at least in my mind, it's important not to treat that like an obligation and a chore, and see it for what it is, which is a fantastic way to measure the health of your org and the health of how good a job we're doing. So I've been talking about how important testing is, and I've done that for the last couple of years, but what I've realized more recently is that visibility into the results is just as important. If you've got all these good unit tests but you don't know what's happening to them, you don't know across all your environments, then they're not giving you the right payback that you deserve. The first sort of problem with getting visibility into your unit tests is that they don't run automatically. They only run typically when you come to do a deployment. So if something's changed in the intermediate 2 weeks or whatever time since your last deployment, then if somebody's changed the shape of the data, or if the unit test wasn't maybe just as well written as it could have been, then your test will start to fail when it comes to the deployment, and you've sort of got 2 problems now. You have to fix the unit test. Maybe that wasn't even written by you, and your deployment window is shrinking as well. Tracking across all your different environments as well can be very difficult. So, maybe you're a very diligent admin or dev and you're making sure your unit tests are always green. But what about your colleagues? What about the staging environment? What about the org you set up for the contractors? Is code coverage dropping a little bit? It'd just be nice to have that visibility across all the environments. And as I mentioned, around this requirement for deploying to production, silent failures can really bite you, and they bite you at the absolute worst time. So it's important to have visibility into the status of test results, and really to then realize the benefits of your investment. Right, writing these unit tests is expensive. It's time consuming. To realize the benefits of it, you need good automated testing and also good visibility. So how can we automate testing? There's a few different ways. One of the things we've heard a tremendous amount about at this conference is Salesforce DX. And Salesforce DX provides a new way to run tests. So rather than you have to watch me type out all of this code, I'm just going to play a video of SFDX CLI doing its thing. You basically go to your workspace where your Scratch org exists. You do SFDX, force test, run. A moment or two later, it will ping up to the cloud. It'll tell Salesforce to run all of those tests for us. It'll poll repeatedly until it gets the results. And in a second or two, it'll print out a table showing us, exactly, how long our test took to run, what the code coverage was like, and finally a summary across all of those things. So very easy to do. I recommend you try it out, or the Salesforce DX booth is down there as well. You can get a hands-on demo of some of this stuff. But that's first of all not super easy. You have to be comfortable with CLI tools, and also it's sort of just for that one org. So now you still have to collect this across all your different environments, and that's a bit of a pain. So we've actually built a free feature into GearSet to do this for you, and it'll run unit tests across all your environments and catch any failures. So if I switch to my browser, to get started with GearSet, you just go to gearset.com and press login. Once you're logged in, you can ignore all of our metadata migration stuff if you want to, and just jump straight to the test monitoring. So as I said, this is free. We give this away. Anyone can use it. The first time you log in, you'll be on our enterprise trial for 30 days. But beyond that, this will all still keep working. So here you can see a few different environments that I've got set up. But if I wanted to add a new org or a new environment, I can come over here. First of all, choose what time I want my unit test to run. So ideally, midnight local is great, right? Just outside of working hours so that I'm not impacting any of my users. Give it a name. So typically, this would be your production monitoring. But it can be anything you want. So I think, I'll choose a bunch of different orgs, but I've got one here. So as we said, at 75%, Salesforce is going to start to give you a hard time about code coverage. So maybe as a team, you want to agree 90 is more where you want to be. So now every 24 hours, GearSet will run all of your unit tests for you. And if there's any failures, then we'll either send you an email, text message to your cell, and then some team chat options around Slack, Microsoft Teams, or of course Chatter. So I'll just press save, and now that's going to run. So if we look at one that's been running for a while, then we can see it's currently green and code coverage is good, but it has failed actually quite recently in the past. I can jump in, I can drill down to my failed tests, and I can see exactly what has failed, and now I can jump in and fix it. So it provides a very easy way to do your unit testing.
So it's obviously important to automate your tests and to get those tests running so that you get the results. But one of the other key points is having visibility into what's going on in those tests. There's no benefit to you having all the tests automated in the world if none of you know what's going wrong with them, and then you obviously don't go in and fix them. So how can you improve visibility into the results of those tests? Well, I think first it's important to talk a little bit about what effective visibility is. And we think there are three key components to that. And the first one is accessibility. So you need to make sure that anyone who needs access to see the results of those tests can do that with minimal effort. If you have to go through hundreds of hoops, you have to download bits of products, you have to find your source control code, you're not going to get the results of those tests and you're not going to fix those problems. Secondly is key messaging, is clear messaging. So you need to make sure that when someone does go and have a look at see that tests, they need to know if it's passing, if it's failing at a glance, without having to spend too much time thinking about it. And then they can obviously prioritize their response in accordance to that. And then finally, as Kevin mentioned, is automation. So you need to make sure these test jobs are running on a regular basis so that you can proactively go and solve those tests before they become a deployment blocker, rather than only finding out about them when you actually come to push a release. So there are a few different ways that you can obviously increase the visibility into those tests. This talk is about IoT, and one of the ideas we had was how can we actually make it practical for you to see the results of your tests right there in your office. You don't have to open up any software, you don't have to look anywhere, you can have something mounted right on the wall to see the results of that. And what we came up with is the idea of this own wall of success. For those of you who can't see it at the back there, we obviously have it sat here on the front, glowing in all its glory, but you've got a photo of it up there. And the principle behind this is it represents the status of our 4 different orgs. So in this case, we've got a developer environment working in, we've got an integration sandbox, we've got a user acceptance testing, and then finally we've got production. And the idea behind this is we then represent the color of those orgs, which represent the status of the tests in them. If any of you can't see right at the back, we have a little video just showing you what's going on here. But essentially, you've got 3 different environments which are currently showing as green, and you have our UAT environment there, which is glowing as orange, which means that something's up, and we're going to have to dive into that. So what's actually going on behind the scenes here? Obviously, this is IoT. We want to talk a little bit about how it works and how we put it together. The idea behind this was to make it really, really simple, and we used as many off-the-shelf components as possible. So this isn't a serious project. I'm not an electrical engineer. I did this all in the office with a soldering iron and a couple of cables and other bits we bought from online stores. So behind the scenes, the brains here is a Raspberry Pi, which is hooked up behind a fade candy board. And obviously, you've got there a soldering iron, some wires and cables, and a bit of solder to put it all together. LEDs around the outside are a group of NeoPixels, which you can just buy online from a company called Adafruit. And those are just strips of LEDs you can slice up as you need and solder them together. And we obviously got 4 different strips here around our different environments. It's then all mounted on a group of Perspex sheets. Again, this is all straight off online. You can get these pre-cut very easily without much effort. You don't have to have a woodworking shop at home or anything like complex equipment to put it all together. You then have a large and judicious amount of duct tape, which you can't see, but behind the scenes it's holding it all together. And you've obviously got there the wiring and everything, which holds it all behind the scenes. The actual brains hooked up to the Pi is then a little board called a fade candy. This is, again, something you can buy online. I think it's about $25. And this comes with its own bit of software called Fade Candy Server, and is designed specifically to power LEDs without you having to know your own programming, without you having to go into too much detail about it. And you can easily hook this up to a computer, you can power your LEDs, and you can run them without going into too much effort. And you've got the final picture there of the result as we were starting to test it, glowing in all its glory. So the idea is I put this together in a few days in the office using components all bought online. It's not a complex project, but it does give you a way to visualize this in a very practical manner. So what's going on behind the scenes in terms of the software that runs it? Well, the core of it, we have GearSet, as Kevin showed earlier, running test jobs. So every day, it's running against our 4 different environments, our developer, integration, UAT, and production. It's kicking off those unit tests, and we're then tracking the results of the code coverage and the tests. That then is being piped out using a cruise control feed. Cruise control is an open source format which a lot of tools use in order to track the status of test jobs and integration environments. And that's being picked up by our Raspberry Pi. And the Raspberry Pi via the fade candy is then piping out to the different LEDs to change the color of those based on the status of our tests. So at the moment, we've got developer, integration, and production, which are all green. So we know in that case, green means our tests are passing, and our code coverage is above the threshold we've set in our test job in GearSet. And we have...
Sorry, something's just gone.
Oh, in fact, I've just been corrected, actually. We've got integration there has actually started flashing red. So what that means is that actually some of our tests have started failing. So in that case, I'm going to have to dive in and get that solved. This could be a deployment blocker. And I didn't have to go into my software to do that. I didn't have to run around and try and dig into this. This could be sat on the wall in front of my team, and now immediately I have one of my developers coming in to go and fix that, get it back to green so we can go out to release. So it's obviously a little fun project. It's not necessarily suitable for everyone's office, but it's just a way of finding different ways that you can get that information out there to different places to get the problems solved as soon as you need them. This is all available on GitHub as well. So if you come and chat to us afterwards, we're happy to give you the information, and you can grab this software, you can start playing around with it for yourself, and we'll talk as well about the hardware and software at great length if you want to try and build your own projects and work on this.
So Jason actually has downplayed, his skill set there a little bit. It is all off-the-shelf components, but it's not super trivial to set up, and there's definitely some frustrated moments of watching him burn his fingers on soldering irons. So we wanted to find another way to make this really simple to expose the visibility of your unit tests, make sure that if they're failing that you know about it without you maybe having to do all of this. And as Jason mentioned, we've actually built this functionality. It's free, and it's built on top of an open standard called CCXML. And there's a whole ecosystem of tooling built around this format. There's a few for Mac, CC Menu, and then on Windows you've got CC Tray. There's even ones for your phone where you'll get notifications when your tests have started failing. Just to sort of show you how easy that is to set up. Back over in GearSet, if I go to my team page, if I scroll down a little bit, you'll see this test notification feed URL. And that's this open format that's going to let me know exactly where my test failures are. So we've previously installed CC Menus. This is a free piece of software which you can run. You just jump in, drop in that URL, press continue. We can see here all the different environments, so I don't have to run into each of my individual environments to grab the results. I can see it across all of them. So let's select all of those, add that, and now up in my menu, if I can get him to come back, you can see there already that there's the failures being highlighted, and I can jump in and jump directly to int. Oh, and if the browser was working better, then that would have taken us straight to gear set. But you can trust me that it does it. You'll get to see that same stack trace that we saw earlier. Okay. So that's a way more practical way, a way more sort of pragmatic way of showing test visibility without having to do a bunch of soldering.
But I don't think it's all necessarily about the practicality. I think some of the power of IoT and the beauty of playing around with this kind of software is you can actually have a bit of fun, and you can make it not only practical, but a bit of interesting to work on it in the first place. So if I were to jump back to GearSet, for example, and I go to my test menu, and let's say we take our developer environment here, and what I'm going to do is I'm just going to change the name of this job. We're going to change it from dev, and since we're at Dreamforce, we're going to call it DF17 and hit save. And what you're going to see in a second here is that, there you go, our developer environment now has turned a lovely shade of rainbow colors. It's flashing all sorts of different ones all over the place. It's obviously a little Easter egg we built into the product, not particularly useful in terms of working out what's going on with your tests, but again, it's just an example of the kind of fun you can have when you're building this project. And really, when you're working with IoT, if I can get back to slides, when you're working with IoT, the only limit is really your PowerPoint slides and your imagination. So you can craft this in any way that you need. If you've got a business that works in specific ways, you want 4, 5, 6, 7, 8 orgs, you can do that pretty easily, and you can craft this to do exactly what you want. So what are a few takeaways then from the talk today? Well, firstly, as I'm sure you're all aware, testing's important. You have to write tests, and it's important that you run them regularly, but so is visibility into the results. So you need to make sure that you can write good tests, you can execute them regularly using automation, but then key is that you actually have people being able to see those results and then action them. And that's where you can have a bit of fun and be a bit creative. You obviously don't have to build your own board like this, although if you want to, we'll happily talk to you about it in more detail. You can go through cruise control and use a completely free bit of software there combined with GearSet's free test runner, or you can have it using different tools as well. And if any of you have questions about how we did this, there's obviously only a certain amount of information we can go into here in a talk about all the hardware and the software and the design behind this, then we're happy to talk about this in more detail. If you want to build your own projects like this, you can grab the software off GitHub, and you can come and talk to us afterwards. We have a booth just around the corner. Or if you take your own ones and send us pictures and things like that, then you can tweet us at GearSet HQ, and we'll be happy to go through this in more detail. Thank you very much. I hope you found that a useful talk.